Welcome back. In this video, I am going to talk about another sorting algorithm named selection sort. In this technique, we find the smallest element and place it in the appropriate position. And selection sort is a simple but inefficient sorting algorithm, and it is a combination of searching as well as sorting. We will see how it works. In this, the list is divided into two parts. The first part is the sorted part at the left end, and the second part is the unsorted part at the right end. Initially, the sorted part is empty and the unsorted part is the entire list of elements. The smallest element is selected from the unsorted array and swapped with the leftmost element, and that element becomes a part of the sorted array. This process continues, moving unsorted array boundary by one element to the right. Each time selecting an item according to its ordering and placing it in the correct position in the sequence. We will see the example, then you can able to understand it clearly. Let me take an array A with 5 elements indexing from 0 to 4. As we all know that if the array is having n elements, it requires n minus 1 pass to sort the array. So here this array is having 5 elements, so it requires 4 pass to sort the array. In the first pass, the smallest element is searched between a of 0 to a of 4 and swapped with a of 0. You can find the smallest element from the array A, that is 1, in the index position 4. So the smallest element 1 will be swapped with the left end element, that is 3. After swapping, the array looks like this. The red color labeled index element is in sorted order now, and the remaining elements are in unsorted subset. In the second pass, the smallest element is searched between a of 1 to a of 4 and swapped with a of 1. In the above array, you can able to see that the smallest element is 2, and this element should be swapped with a of 1. What is the a of 1 here? The a of 1 is 7. So the 2 should be swapped with the element 7. After swapping, this is the array we will get. Here 1, 2 elements are in sorted and the remaining 6, 7, 3 are in unsorted. Now in the third pass, the smallest element is searched between a of 2 to a of 4, as a of 0 and a of 1 is already sorted, and the smallest value should be swapped with a of 2. So as we know that from the above array, the smallest element is 3 and it should be swapped with the a of 2 element, that is 6. After swapping, this is the array. And we are having 2 more unsorted elements. And take the fourth pass. The smallest element is searched between a of 3 to a of 4, and that smallest element should be swapped with a of 3. From the above array, the smallest element is 6 and that should be swapped with a of 3, that is 7. After swapping, this is the array. So now this array is sorted, and finally we will get the array A with sorted elements. Now we will see the algorithm of selection sort. This algorithm sorts the array A with n elements. So name the algorithm is selection sort with array A and n elements. Let's begin the algorithm. First, we run one loop with I that runs from 0 to n minus 2. 0 to n minus 2. And in each iteration of this loop, we will set the element at ith position appropriately. So, first we put minimum at 0th position, then we put second minimum at first position, then we will put third minimum at second position, and so on. So this loop will execute n minus 1 times, because we know to sort elements we need n minus 1 pass. Since we have starts from 0, so it will run up to n minus 2. Now inside this for loop we have another variable that will store the minimum value, so that set min equal to I. Then we will scan the array from 1 to n. So while scanning, if we find any element at index j which is less than minimum, then we update the variable min by set min equal to j. Okay. Sorry. Yes. If a of j less than min, we need to set min equal to j. Now if ended, inner for loop ended. Now swap the elements with ith value. So take temp equal to a of I equal to a of min, and a of min equal to temp. As we all know that, so this is the logic for swapping of two numbers with temporary variable. After swapping, end the for loop and end the algorithm. Now we will calculate the complexity of this selection sort. To calculate time complexity, the time will be measured by considering the number of comparisons the algorithm takes. So for n elements of an array, in first pass it requires n minus 1 comparisons, and in second pass it requires n minus 2 comparisons, and in third pass it requires n minus 3 comparisons. Like that, in kth pass it requires n minus k comparisons, and in the last pass it requires 1 comparison. So the total number of comparisons are f of n is equal to n minus 1 plus n minus 2 plus n minus 3 plus and so on, 3 plus 2 plus 1, and it gives n of n minus 1 by 2 as big O of n square. So finally, the final time complexity of selection sort is order of n square. Okay. Now we will discuss what are the advantages of this selection sort algorithm. It performs well on a small list because it is an in-place sorting algorithm. That means no additional temporary storage is required beyond what is needed to hold the original list. Its performance is easily affected by the initial ordering of the items before the sorting process. Because of this, the selection sort is only suitable for a list of few elements that are in random order. Now we will see what are the disadvantages of this selection sort. The primary disadvantage of the selection sort is its poor efficiency when dealing with a huge list of elements. The selecting sort requires n square number of steps for sorting n elements, and this algorithm is not suitable for large data sets as its average and worst case complexities are of order of n square that we have already discussed in the previous slide, where n is the number of elements. So these are the disadvantages of selection sort. So hope you all understand what is selection sort algorithm is. Thank you.